Okay, in this Math 2, for Chapter 2, we're only going to do 17 and 18 in this section. The first one is actually kind of, I'm just going to give you the answer because I want to get to the concept more than I care about the flow chart. So, in an isosceles triangle, two angles opposite the congruent sides are called the base angles. You may have heard of these. You may have learned in a previous course that the base angles of an isosceles are congruent. There's actually a homework problem, there's actually a problem in Math 1 that has you do this. So if you do or do not remember, now you will prove it. So in the diagram at the right, SYM is an isosceles triangle and point E is the midpoint of SM. So I'm going to zoom in really quickly so you can see what we're talking about. Okay, so there you go. And it says that it's an isosceles triangle. So that means two of the sides are the same. And then your, I shouldn't say your point, the point E, which is this point down here, is actually literally halfway in the middle between S and M, which means that this part right here is going to be equal to that part right there. Since point E is the midpoint, it means it cuts segment SM in half and makes two equal parts. Now, the part about this one that you should notice right away is that there's two triangles stuck together. So when that happens, you have the reflexive property at work, right? Because something is equal to itself, which is basically YE. If you take these two triangles and like unstick them together, then YE is the same for the triangle on the left as it is for the triangle on the right. We call that the reflexive property because it's congruent to itself. And so that would be the third one, right? So now you have two triangles, and then you have side angle side, side angle side, and that is enough to prove that these two parts are equal, which basically then turns into, if you know all these three sides are equal, then the angles inside must be equal too, which gets to the actual result, is what we wanted to do, which was that the base angles, which the ones I'm going to highlight right now, angle S and angle M, those two angles are also congruent to each other. Because the two triangles are equal, those two parts, which are corresponding parts to those two triangles, they're also going to be congruent. Please notice I didn't do anything about doing a right angle or anything like that in there. We're just going to talk about those two triangles. These two angles in there. So the flow chart should look something like this. Now, since you don't have numbers on here, if you want to, you can always say, okay, you can always do these at the top. You just leave them blank if you want to. But for right now, since we don't have any numbers, we're going to drop straight to the sides themselves. So in the first one, they say, okay, so YS and YM are equal to each other, so they're congruent. That's a given because it came like that in the problem, right? So the two markings were already drawn in the picture for us. And then YE is congruent to YE. Now, the reason it says segment is congruent to itself, I would prefer if it said reflexive property in your paper, because technically that's the actual property, and we want to stick with the properties as our reasons. And then SE is congruent to EM. That's a definition of a midpoint. What it should have said, actually above here, I don't really like the fact that they jumped right into the definition of a midpoint. What it should have had a bubble up here, that would have been nice, that said point E, that basically said this line right here in that bubble. E is the midpoint of SM, and that would have been a given because it gave us that information. And then, since E is the midpoint of SM, that means these two parts, like I was saying earlier, are equal to each other, and that's a definition of a midpoint, E being the midpoint that we're talking about. That should have really gone in that area right there. So now we had what I was referring to earlier, side, side with the three sides, right? the one that we're given, the reflexive property one, and then the definition of midpoint. So we had side, side, side. There's your congruence statement. And since all three sides are equal, then all the angles must be equal too, which means that angle S must be equal to angle M. Because congruent triangles gives you congruent parts, right? Congruent triangle gives you all of the congruent angles, all of the congruent sides, and basically just congruent parts. Okay, we're going to add this theorem to our graphic organizer when we get to school, but we'll leave that for right now. So, next one, determine the area of the following figures. Assume that all angles that look like right angles are right angles. Okay, well, that helps. So, that actually helps a lot. First one, I call it the upside down flower pot. Because you can, like, if I just flip this around, it looks like a flower pot. And then you're just like, woo, I have a little flower up there. All right, so we're going to look at this really quickly. Right away, I'm looking at this, and my thing is, okay, this is not a normal shape, so I'm going to have to break this apart into maybe a couple of different shapes to get the area of them. And one thing you should notice is that's why they kind of have this dashed line over here. So one area would be really easy to find the calculate for would be this bottom part, which is your rectangle. So right away, the area of the rectangle piece, right, is just base times height. That's just a normal area of any rectangle. So 2 times 8 should give you 16. We have feet, right? So 16 feet squared. That's the area of the rectangle. Now, the area of this top part, which is actually a trapezoid, if you can see it a little bit better. Now, your trapezoid has a base of 4, right? And I'm going to write the formula down because I'm pretty sure you forgot it from the last homework assignment. Base 1 plus base 2 times the height all over 2. So you have a base 1, which is the top part. You have base 2 goes from this corner here to this corner here. That's your base 2. It's not 8. 8 is the whole bottom piece. And we got to figure out what that is. Shouldn't be a problem. So this part right here is 1. This part right here is 1. So that's 2 altogether, which makes this whole orange piece here a 6. So this is going to be your base 1. This is going to be your base 2. And you have your height of 3 feet, right? Because it's making a 90-degree angle with the bottom and the top. So that gives us an area of 4 plus 6 all times 3. And divided by 2, so that gives us 10 times 3 divided by 2, and whatever it is, it's feet squared, right? Whatever you get for the area of the trapezoid. And then your final answer should be adding them up. So you need to sum up area of the rectangle, and you need to add it together with the area of the trapezoid to get your final area of that upside down flower pot. Okay, the next piece. It looks like we've got 2 triangles and a rectangle in here. Okay, so the area of the rectangle shouldn't be too hard. It's just 30 feet squared. Okay, so that's this inside part, right? Now, the area of this triangle at the top should give you formula for the area of a triangle. Area of any triangle should be base times height divided by 2. Now you have your height, which is 3. You don't have this part, but that's really easy to calculate. That's just 5 because it's the same thing as bottom. So area of triangle number 1, or the triangle at the top, should be base. So 5 times 3 divided by 2, so you get 8 divided by 2, so you get 4. I'm going to skip units for right now. Actually, no, I'm not. 4 feet squared. So this little top triangle is 4 feet squared. Now, this bottom triangle, your base is 4 and your height is 2. So the other triangle, your base is 4, your height is 2, all divided by 2. So you should get 8 divided by 2 should get 4 feet squared also. Yay! So now the only thing that you have left to do is put them all together. So you need to find the sum of this part, and the last rectangular piece right there. All right. that is the areas of those two figures. You did not need to do perimeter, thank God, because there's no way you would have been able to do that. So I will see you guys later.